Welcome to the official podcast series by POTENZA, where innovation meets insight. In this series, we dive deep into the world of SAP, explore the power of robotic process automation, and unlock the true potential of data analytics. Whether you're a tech enthusiast, a business leader, or just curious about the digital transformation shaping our world, you're in the right place. Tune in, stay curious, and let's explore the future of enterprise technology together. Don't forget to subscribe and follow us on YouTube for more powerful insights. Now, let's get into today's episode.
Imagine standing in front of your company's board of directors, right? Like you are the head of sales.
Oh boy, high pressure situation.
Very high pressure. So you pull up this beautifully designed, super colorful dashboard on the projector.
Right.
And you confidently report a triumphant, let's say, $10 million in quarterly revenue.
Everyone's clapping, popping champagne.
Exactly. Everyone claps.
Yeah.
But then the head of finance stands up.
Oh, no.
Yeah. They pull up their own sleek dashboard right from the exact same company database, and they report a $2 million loss.
Wow. Yeah, the oxygen completely leaves the room at that point.
Utter silence. And the question is, who is lying? But the terrifying answer is neither of them. And that is why we are welcoming you to our deep dive into the invisible war of data storage.
Yeah, that scenario is basically the ultimate boardroom nightmare. And the wild thing is it happens far more often than anyone actually wants to admit.
I mean, we all expect absolute precision from our business metrics, right?
Right, totally. A blue bar goes up, a red line goes down, and we naturally assume that represents objective reality.
Right. But behind those crisp, authoritative visuals is this, well, massive chaotic infrastructure that almost everyone completely ignores.
Which is exactly the mission of our deep dive today.
Yeah, we are pulling from a really incredibly detailed guide on business intelligence or BI reporting architecture.
And our goal here is to really demystify this invisible foundation.
Because the harsh truth, which is laid out pretty starkly in these sources, is that poor data storage doesn't just make your dashboards load a little slower.
No, not at all.
It silently and invisibly corrupts the actual quality of your reporting.
It leads to missed trends, conflicting numbers, and basically decisions built entirely on sand.
Exactly. So if you've ever stared at a business metric on a screen and thought, that just doesn't look right, this deep dive is going to explain the actual mechanics of why that happens.
It's a fascinating journey, really.
Okay, let's unpack this. To really understand why modern data can be so messy, we actually need to look back at how the industry originally tried to keep it perfectly, almost obsessively clean.
Right, so to do that, we have to travel back to 1989.
1989, wow, okay.
Yeah, the guide we are looking at highlights this man named Bill Inman.
Right.
And he formally introduced the concept of the data warehouse. He is widely recognized today as the father of data warehousing.
And his vision was actually pretty radical for the time, wasn't it?
Oh, completely radical. He envisioned this centralized, highly integrated repository where data from all across a totally fractured organization could be pulled together.
Right, pulled together, scrubbed clean, and just made consistently available for analysis.
Exactly. And then shortly after that, the sources note that Ralph Kimball came in.
Yeah, Kimball. He popularized this idea of dimensional modeling.
Right, because before that, you were storing data in these abstract, highly technical formats that, honestly, only database administrators could read.
Yeah, so Kimball suggested, hey, let's organize it around actual business subjects.
Right, things like sales or customers or inventory.
Because the whole goal was to make this massive repository accessible, so a regular business analyst could actually use it to find answers.
Exactly, and to really appreciate how transformative that was, you kind of have to look at the underlying mechanics of a traditional data warehouse.
Right, how it actually operates.
Yeah, it operates on a concept called the schema on write model.
Schema on write, which, that sounds incredibly technical.
It does sound a bit dry, yeah.
But the way I've always conceptualized it is having a really strict bouncer at the door of an exclusive club.
Oh, I like that.
Yeah, the bouncer has a list of rules, the schema, and if you don't perfectly match that list, dress code and all, you are just not getting inside.
That is a brilliant way to frame it, actually.
Yeah.
Before any piece of data is allowed to cross the threshold into the warehouse, it has to be standardized.
Right, and the industry refers to this pipeline as ETL, right?
Yes, extract, transform, load.
So first, you extract the data from, whatever source system actually generated it.
Exactly. Then you transform it.
And that transformation is the heavy lifting.
Right. Oh, absolutely.
Oh,
This means scrubbing out errors, standardizing dates, so they, all follow the exact same format.
right. Making sure everything aligns with that predefined blueprint we talked about.
Yep. And only after all of that transformation is complete, only then do you actually load it into the warehouse.
Let me bring in another analogy here, actually, that always clicks for me when thinking about these ETL pipelines.
Yeah, go for it.
Think of a really high-end restaurant kitchen.
Okay, I'm with you.
The data represents the raw ingredients being delivered to the back door. But in a data warehouse model, those ingredients do not just get shoved into a pantry.
Right, they aren't just sitting there in cardboard boxes.
Exactly. The moment they arrive, a whole team of prep cooks grabs them. They are washed, chopped, peeled, and portioned out into these very specific, uniform little containers.
And all of that prep work happens immediately.
Instantly. So later that night, when the head chefs actually need to cook, which is, the equivalent of a business user running a report, they can move incredibly fast.
Right, because everything is already prepped, perfectly uniform, and exactly where it should be.
It's all ready to go.
And honestly, if you were a bank or a major retailer in the 1990s or early 2000s, this prep kitchen model was an absolute dream.
I bet. It sounds super efficient.
It was, because early adopters of the data warehouse, they dealt almost exclusively with structured transactional data.
We're talking like daily sales receipts.
Exactly. Sales receipts, inventory counts, really basic customer records.
Things that fit just very neatly into standardized rows and columns.
Right. When you have highly structured data, the warehouse model handles it brilliantly.
Because it's validated by that bouncer before it even arrives.
Exactly. So your analysts can query massive volumes of it with absolute confidence.
Which is why we still see the evolution of this rigorous structure today, right? Like with premium tools such as Snowflake or Amazon Redshift and Google BigQuery.
Absolutely. Those are the modern titans of that model.
But, a perfectly pristine restaurant kitchen is really only great if you only ever cook one type of meal.
That's the catch, isn't it?
It is. Like if your restaurant only serves steak, a rigidly organized steak prep kitchen is fantastic. But then the mid-2000s arrive.
The game changes completely.
Totally. The internet absolutely explodes, the smartphone is invented, and the entire menu just completely changes.
Right.
And reading through these sources, you can see how that rigid, highly structured warehouse model just started to, fracture under the weight of the modern web.
It really did. The guide details exactly how that fracture happened, and it wasn't just one single thing. It was a combination of massive technological shifts.
The 5 mounting pressures, right?
Exactly. First, we had the sheer volume. I mean, the conversation shifted almost overnight from megabytes and gigabytes to petabytes.
Petabytes. That's just an unfathomable amount of information.
It's staggering. And the explosion of internet activity meant that storing every single piece of a company's data in a highly structured premium warehouse just became financially devastating.
Yeah, I imagine the licensing costs for legacy vendors at the time, like Oracle or Teradata, they must have been astronomical.
Oh, completely unsustainable for that volume.
And it wasn't just the sheer amount of data, right? It was the completely bizarre new formats it was arriving in.
Yes, the variety.
We aren't just looking at neat little sales receipts anymore. People are, uploading millions of photos.
Right.
They are clicking randomly through web pages, which generates these massive, totally chaotic server logs.
Yeah, and how does the neat little row and column warehouse handle like a raw audio file from a customer service call?
It doesn't.
It fundamentally cannot. A warehouse is built for structured text and numbers.
Right.
But suddenly companies realized there was this massive untapped business value hiding in unstructured data.
Like social media sentiment, right?
Exactly. Social media, video files, sensor data from connected devices. You just cannot put a waveform or a photograph into a database row without stripping away its essence.
No, you'd lose everything that makes it useful. And on top of that variety, you have the issue of velocity.
Yes, the speed at which this new data arrives.
It is no longer just a daily batch of receipts dropped off at midnight. We are talking about continuous, real-time streaming data.
Right.
Going back to our kitchen analogy, it's like the prep cooks suddenly have food being thrown at them through the window at 100 miles an hour.
Good luck chomping that fast.
Exactly. Those traditional ETL pipelines were designed for slow, overnight batch processing. They simply could not chop the vegetables fast enough to keep up with the real-time speed of the modern internet.
They were completely overwhelmed.
But wait, let me push back on something you mentioned earlier about the cost, though.
Okay, sure.
Let's look at the biggest companies in the world during that internet boom. The major tech giants, the massive global banks.
Right, the ones with deep pockets.
Exactly. They had virtually unlimited budgets. So if the data warehouse is so secure and so deeply trusted for boardroom reporting, why didn't these massive organizations just write the check, hire more engineers, and build infinitely bigger, faster warehouses to hold everything?
If we connect this to the bigger picture, we see that it actually wasn't just a budget issue.
Oh, really?
No, it was a fundamental architectural mismatch. And it was driven by a totally new type of employee.
Who is that?
Well, by the late 2000s, we see the emergence of the modern data scientist and the machine learning engineer.
Ah, okay.
And according to the sources, these experts absolutely did not want the pre-cleaned, pre-structured, perfectly chopped vegetables from the warehouse.
They didn't want the clean stuff. They wanted the raw ingredients, dirt, roots, and all.
They absolutely demanded it. Machine learning models require raw, unprocessed, highly granular data to find those hidden patterns.
Oh, that makes sense. Because if it's already processed, you've lost the nuances.
Exactly. Think about what happens when you run data through an ETL pipeline to fit it into a warehouse schema.
You're filtering it.
Right. You are inherently making human decisions about what information is important and what can be stripped away or averaged out.
Right.
But for a data scientist trying to train an experimental predictive model, that pre-filtered data is functionally useless.
Wow. Useless. That's a strong word.
It is, but it's true. A seemingly broken sensor reading, for example, might actually be the exact signal that predicts a catastrophic machine failure.
Oh, I see. And if the ETL pipeline scrubs out that broken reading just to make the database look clean,
Then the predictive model is completely blind to it. They need the noise just as much as the signal.
Okay, so you find yourself in this just impossible situation by the end of the 2000s.
Yeah.
You have warehouses that are incredibly expensive, way too slow to handle real-time streaming, totally incapable of holding video or audio, and deeply frustrating to your most advanced, highly paid data scientists.
It was a breaking point.
It really was. Because the rigid warehouse couldn't handle this tsunami of fast-moving, unstructured data, the industry had to invent a fundamentally new approach.
And that brings us to the year 2010.
Enter 2010.
The sources pinpoint 2010 as a massive turning point. That is when James Dixon, he was the CTO of POTENZA at the time, coined a brand new architectural concept.
The data lake.
Yes, the data lake.
And his analogy for this is legendary in the tech world, and honestly, it is so helpful for visualizing the shift.
It really is the perfect way to explain it.
He argued that a data warehouse is like a bottled water store, right?
Right, the water's already filtered, it is packaged in a uniform plastic bottle, it has a label.
And it is ready for one very specific, predetermined use drinking.
Exactly. But a data lake is like a natural, wild body of water.
Right. Raw water flows in freely from hundreds of different streams and rivers.
And users can just come down to the shore and draw from it in whatever form or quantity they actually need.
That analogy perfectly captures the reversal of the underlying architecture.
It really does. Remember how the warehouse used a schema on write model with the strict bouncer at the door?
Yes, very strict.
Well, the data lake operates on a schema on read model.
Schema on read, so the bouncer is gone.
The bouncer is completely gone. Data is ingested into the lake in its completely raw, original form.
Whether it is structured sales data, semi-structured JSON files, or totally unstructured video files, it just doesn't matter.
It doesn't matter at all. The gates are wide open. Structure is only applied much later. At the exact moment, an analyst or data scientist decides to query the data and look at it through a specific lens.
Which means the famous acronym completely flips.
It does.
Instead of ETL extract, transform, and load, it becomes ELT.
Right. You extract the data, you load it immediately into the vast lake, and then eventually maybe you transform it when you actually need it.
And this wasn't just a conceptual shift, right? It was enabled by a massive technological leap.
Absolutely. The sources detail how this was initially driven by Apache Hadoop.
Hadoop.
And without getting too deep into the weeds here, Hadoop essentially allowed companies to ditch the $1 million proprietary supercomputers.
Thank goodness for that.
Right. Instead, they can string together thousands of incredibly cheap, standard, off-the-shelf computers to hold massive files across a distributed network.
And over the next decade, this concept evolved into the cloud object storage we rely on today, right?
Exactly. Services like AWS S3 or Azure Data Lake Storage.
Which offer practically infinite, ridiculously cheap storage capacity.
It's almost too cheap, in a way.
Okay, here's where it gets really interesting, because I am listening to this shift, and I am thinking about basic human nature.
Oh, I know where you're going with this.
Right.
Yeah.
If you tell a massive global corporation, hey, stop worrying about formatting, just dump all your unstructured files, your millions of server logs, your raw audio into this giant, cheap digital hole in the cloud, and we will worry about organizing it someday in the future.
Yep.
Aren't you basically just creating the world's most expensive, chaotic junk drawer?
Yes. Yes, you are.
If there are absolutely no rules at the door, how does anyone ever find anything?
You have hit on the exact vulnerability of the entire system. The industry actually coined a very specific, dreaded term for this inevitable outcome.
What's the term?
The data swamp.
A data swamp. That sounds awful.
It is awful. The infinite flexibility of a data lake is undeniably its greatest strength.
Right.
But without rigorous management, aggressive cataloging, and strict governance, a lake stagnates very, very quickly.
It turns into a swamp.
Exactly. It becomes a swamp where petabytes of data physically exist on a server somewhere, but nobody knows where it is.
Nobody knows who owns it, what it means, or whether it is legally compliant.
Right. The data is technically there, but it cannot be trusted.
And that transition from a technical storage architecture to actual human trust is where this stops being an abstract IT problem and becomes a massive, tangible business problem.
A huge problem.
Because the technical differences between a highly curated warehouse and a wild, unmanaged lake literally dictate the everyday reality of the reports you and I look at.
The architecture dictates everything.
It really does.
The sources break down exactly how your storage choice impacts 3 critical dimensions of reporting accuracy.
Okay, let's go through those. The first dimension is data freshness, right?
Yes, because warehouse ETL pipelines usually rely on those overnight batch schedules, that beautiful, polished dashboard you were looking at in a morning meeting.
It might actually be reflecting reality from 48 hours ago.
Exactly. Data lakes, conversely, are built to ingest real-time streaming data without breaking a sweat.
But then you run headfirst into the second dimension, data consistency.
Right, which is the warehouse's superpower.
Exactly. Warehouses literally force consistency. That is the entire point of the bouncer at the door, standardizing the dates and the currencies.
Yeah. But lakes, because they are so free-flowing and raw, carry a massive risk of generating conflicting metrics.
Like if multiple people try to analyze the same raw data using totally different methods.
Exactly. Which brings us all the way back to our boardroom nightmare and the third dimension, data trust.
Ah, yes. The boardroom nightmare.
The guide uses that exact boardroom scenario we talked about earlier to illustrate what happens when data trust completely collapses.
So you have the head of sales and the head of finance presenting wildly different revenue figures for the very same quarter.
Right. And why did it happen?
Well, because the organization was running a poorly governed data lake, a swamp, essentially.
Exactly. The sales team's dashboard was drawing from one raw data stream, and they applied their own unique transformation logic to define what revenue even meant.
Meanwhile, finance was drawing from a totally different, unreconciled raw stream and applying a completely different set of accounting rules.
And chaos ensues.
So what does this all mean? If I am a listener just trying to run a reliable department and my team brings me conflicting reports, my very first instinct is usually to blame the software.
Oh, of course. Everyone does.
Right. I assume the dashboard is broken or the BI visualization tool is just glitching out.
This raises an important question, doesn't it? As humans, we naturally blame the visible layer because, well, it is what we interact with.
Yeah, we blame what we can see.
But the sources emphasize that a report questioned in the boardroom is almost never a failure of the reporting tool itself.
Oh, really?
It is almost always a storage governance problem. It is a failure at the foundational level.
Wow. So that slick dashboard is really just a mirror.
Exactly. It's just a mirror. And if the reflection is distorted, it is simply because it is reflecting the chaos of the data swamp right beneath it.
So you end up caught in this impossible, infuriating bind.
You really do.
If you rely purely on a traditional data warehouse, it is too rigid, too slow to capture real-time events, and way too expensive to hold the raw data your machine learning teams desperately need.
Right.
But if you rely entirely on a data lake, it is cheap and flexible, but you risk creating a toxic data swamp that just destroys all boardroom trust.
It's a catch-22.
So how on earth do modern data-driven organizations actually survive this?
Well, they survive by essentially calling a truce and forcing a marriage between the two concepts.
A marriage.
Yes, we have officially entered the era of the data lakehouse.
The lakehouse. I have to say, I genuinely love the tech industry's absolute commitment to the bit here.
Oh, they lean right into it.
They do. We started with a warehouse, we flooded it to make a lake, so naturally the only logical next step was to build a lovely little house on the lake.
The naming convention is definitely a bit on the nose, I'll give you that. But technologically, it is a brilliant solution.
It sounds like it.
Platforms leading this evolution, like Databricks and Delta Lake, have essentially built a hybrid model.
A hybrid, okay.
Yeah, a data lakehouse merges the low-cost, infinite scalability of a raw data lake with the strict governance, reliability, and structured querying power of a traditional warehouse.
And the sources actually explain the mechanics of how this works, and it is fascinating.
It really is.
You aren't physically moving the data back into an expensive proprietary warehouse.
No, not at all.
You keep the ultra-cheap cloud storage of the lake, but you build the sophisticated metadata and transaction layer right on top of it.
Exactly. And this layer acts like a warehouse. It supports things like AC transactions, which, basically ensures that if a data update fails halfway through, it rolls back cleanly instead of leaving a corrupted mess.
So you get the best of both worlds.
You do. But building that hybrid foundation is incredibly complex.
I can imagine.
The guide outlines several strict principles you must follow if you do not want your shiny new lakehouse to just slide right back into the swamp.
Right. Nobody wants a swamp house. So what's the first principle?
The very first principle is scalability.
Scalability.
You cannot architect a system based on the data volume you have today. You just can't.
Right, because it's always growing.
Exactly. You have to design the architecture to handle the petabytes of data you will inevitably generate 3 to 5 years down the road, utilizing elastic cloud compute that can grow with you.
That makes total sense. And the second principle is governance, which we touched on earlier with the swamp.
Yes, crucial.
But here it means establishing crystal clear data ownership, enforcing strict naming conventions, building searchable data catalogs, and implementing hard access controls.
Right. And the crucial takeaway from the authors here is that governance is near impossible to retrofit.
You can't just slap it on later.
No, you absolutely cannot pour a billion unstructured files into a cheap cloud bucket and then decide, hey, let's organize them a year later.
Good luck with that.
It has to be built into the architecture from day one.
Got it. And the third principle is integration.
Yes. Your underlying storage layer has to connect seamlessly with your modern reporting tools, your transformation pipelines, and your operational systems.
But even if an organization aims for all of these principles, the guide warns that pitfalls are just everywhere.
Oh, they are everywhere. A major one is data silos.
Where different departments stubbornly hoard their own data in separate cloud accounts, right?
Exactly. Which completely defeats the entire purpose of a centralized lakehouse.
Then you have the massive security and compliance risks.
Oh, those are huge. Think about modern privacy regulations like GDPR in Europe or the CCPA in California.
Right. These laws grant consumers the right to demand that a company delete every single piece of data they hold on them.
Every single piece. Now, if you're operating a murky data swamp and you have no catalog telling you where a specific customer's unstructured data is hiding.
Somewhere among petabytes of files.
Yeah, basic legal compliance becomes a complete nightmare.
Absolutely. You also have to navigate extreme latency demands.
Right, because modern businesses increasingly demand real-time analytics to track things like supply chain disruptions or active fraud.
They need answers now, not tomorrow. And finally, you just cannot ignore the skill gaps.
This is a big one. Managing a hybrid lakehouse architecture requires highly specialized, very expensive talent.
You need advanced data engineers, cloud infrastructure architects, strict governance experts.
Exactly. And if you underinvest in the human beings managing the system, the architecture will naturally degrade right back toward disorder.
Reading through how complex this is, I found one insight from the sources particularly striking, actually.
Oh, what's that?
The most successful organizations, they don't actually try to force a one-size-fits-all solution.
Right.
They segment their data deliberately based on intent.
Yeah.
They route their high-priority, strictly defined business metrics, the crucial boardroom KPIs like official quarterly revenue, straight into a highly structured, tightly controlled warehouse environment.
Yep. Keep the bouncer for the VIP data.
Exactly. But they land their massive, raw, exploratory event logs and sensor data in the lake. They match the storage architecture directly to the business value of the data itself.
What's fascinating here is that it proves this isn't just an IT exercise.
No, not at all.
It requires deep, deep business alignment. So if we step back and look at this entire historical journey.
From Bill Inman mapping out the very first rigidly structured data warehouse back in 1989.
Right, to the internet explosion that just cracked that model in half.
Then to James Dixon introducing the wild raw data lake in 2010 to handle all that chaos.
And finally, arriving at these sophisticated hybrid lakehouses of today.
The underlying technology has transformed beyond recognition.
It really has. But the core human goal hasn't changed one bit.
It hasn't. It has always been about exactly the same thing, empowering humans to make better, faster, and more confident decisions.
Precisely.
The ultimate takeaway from this deep dive is that the quality of your business reporting and the trust you have when looking at that dashboard in the boardroom will always be a direct, unavoidable reflection of the storage foundation beneath it.
You cannot build a stable skyscraper on a swamp.
The foundation dictates the height of the building. Without a governed, scalable architecture, all the slick visual dashboards in the world are just painting over rot.
Well said.
But, diving into the mechanics of how data scientists actually use these systems, it left me with a really provocative thought about where this is all heading.
Oh, yeah. What's that?
Well, the sources explicitly noted that machine learning engineers, they vastly prefer the raw, totally unstructured dirt of the data lakes to train their predictive models.
Right, because human filtering destroys the hidden signals. We talked about that.
Exactly. They do not want the human-curated, structured warehouse data. They want the raw, chaotic feed, completely untouched.
Just give them the swamp water, basically.
Right. So it makes you wonder, as artificial intelligence becomes exponentially more powerful.
Okay, I see where you're going.
Right. And as these models become capable of instantly generating complex, brilliant business insights directly from raw, chaotic swamp data without any human intervention whatsoever, could the highly structured, human-readable data warehouse eventually become entirely obsolete?
Oh, wow.
I mean, if the AI doesn't need perfectly chopped, standardized vegetables to cook a Michelin star meal, why are we still paying millions of dollars to run the prep kitchen?
That is a staggering thought to end on. If the machines evolved to navigate and read the swamp natively, we might not need the bouncer at the door or the schema blueprint ever again.
The entire paradigm could shift one more time.
It absolutely could.
Something to seriously ponder the next time you look at a perfectly clean, crisp chart in a meeting and just assume you are seeing the whole picture. Until next time, keep diving deep.
That's a wrap for today's episode of the POTENZA podcast series, where we decode SAP, automate with RPA, and analyze with precision. We hope you found today's conversation insightful and inspiring. If you enjoyed the episode, make sure to like, share, and subscribe to our YouTube channel, and stay tuned for more deep dives into the technologies transforming tomorrow's enterprise. Got questions or ideas for a future episode? Drop them in the comments, we'd love to hear from you. Until next time. Thank you.